Hi, in this video I'm going to show you how to write the program to um, operate the push button that we just did in the last video. So just to start off with, the push button is just going to, whenever we have it pressed, our light will come on, and when we let go of the button, the light will come off. So as I explained in the previous video, that's how a push button works. It's basically when it's pressed, I'll show you right here, when it's pressed, there's a connection that's being made that's on the inside, and the signal is going through. So we'll be able to see that, and when we let go, that signal will stop going through, and then what we'll do in our program is that when that is detected, the light will go off. So let's create a new Arduino project. So let's expand this here for us. And let's rename this file. So let's save this as. So let's call this push button. And let's store this into our Google Drive in our course folder. So save this under your own programming notes. I'm just going to go to my version of it. So it's under TAJ. And then we have programming notes. And then there was our lights that we did from the previous one. So this one's going to be called push button. So there it is. So at the very beginning, what I want to do is create some variables just so that it makes a program easier to read and also a little bit more robust, so that if we choose to hook up our Arduino a little bit different later on, we just change these variables. So let's create one variable for our light. So just warning in advance, some of the exercises I'm going to have you do afterwards will introduce another light. So what I'm going to do is just create a variable for our green LED, and in this case we're going to use pin number 8. We're also going to have one button, and here we're going to say, and we're going to put this in pin number 5. Of course you can add pin if you want into your variables, variable names as well, just to make it more clear. But in this case, I'm just going to abbreviate it, and notice that whenever I got green LED or button, I'm actually referring to what pin is connected to. I also talked about in our last time when we were programming the light bulb, the LED, is that there's sort of some predefined words or keywords, or really they're variables underneath the covers in Arduino, about high and low. While that's, if you get used to programming Arduino, that may become a little more intuitive. For me, I just like the words on and off, and later on we'll see what the button, whether it's pressed or not pressed. So here I'm going to create some other variables that may say here on is really high, and constant off is actually low. So I'm going to actually use those variables as well. So we go off into our setup. So in all our Arduino code, there's always going to be a setup, and there's always going to be a loop. So in our setup, it only runs once, and basically this is what code that we want to be executed when our Arduino starts up. So in other words, once when it compiles and it loads up the code to Arduino, this is the first thing it's going to do. So we have to set up our pin modes. So first is maybe we'll set up our light, so our green LED. So basically telling that pin 8, well, that's an output. And remember our semicolons, that's going to be one tricky thing that we deal with the programming language for Arduino. Now we have to set up our button. So setting our button is a little bit different. So as I talked about when we were doing the setup or the connection of the button, this is sort of an input into Arduino. This is how we gather information and put that information for a program to process. So that's what the purpose of the button is. The user presses the button, and we won't be able to know when that is happening. So in this case, it's not an output, but it's an input. And maybe the first thing we want to do when we first load a program, the light might be on already from previous things. So just to make sure, we're just going to turn it off. So here we're going to do a digital write. And this is where the variables makes our code a lot more readable. Here we're going to make the green LED off. So that's the very first thing we want to do when we start our Arduino program, is basically set our output and input and turning the light off. So the other part of our Arduino program is what they call the loop. So as a reminder, this is code gets repeated over and over again. You don't actually have to write loop constructs. It's what is actually an infinite loop. This code will get executed over and over and over again until we unplug the Arduino. So we're going to introduce one variable in here, and we just want to know if the button is being pressed. So we're going to introduce a variable to sort of remember that state. So state is something that it's going to be mentioned a lot when we program. So it's sort of what situation a program is in. That's what state kind of means. So in this case, we want to sort of remember what state is our button. And there's two important states that we want to remember, if it's pressed or not pressed. So we want to be able to remember that. So here we're going to create a variable called button state. And how do we sort of get this input? So just like when we were sort of outputting to LED, in other words, outputting our Arduino, we do a digital write. In other words, we want to write a signal to this pin. In this case, it was pin number 8, and we want to turn this pin off. So that's the signal we want, basically sending in a 0. Well, in terms of reading it, well, I just said the word, is that we want to get that input. So what we're going to do is we do a digital read. And here, what is it that we want to read? Well, we want to read the button. And we want to store this into the variable. So I forgot to type that in the very beginning. So here we want to say the button state is I want you to read what's happening with the button. And what we want to do now is a simple condition. Well, if the button state is high, not that readable, so this is where I'm going to go back to the top and introduce another variable. Again, it's going to be a constant because I don't want the value of this variable to change, is this idea pressed, and that's high. Okay, so here we're going to associate pressed with being high or on. So here, if the button state is equal to, I forgot to add the equal sign, pressed, what is it that we want to do? Well, we want to turn the light bulb on. So how do we do that? So maybe let me add some comments in here. We are going to read the status of the button, right? In other words, say status or maybe signal. That is signal of the button. If the button is pressed, then the state would be high. And if the button is not pressed, the state would be low. So there's a nice Boolean. It's either on or off, high or low. So we're going to read that, and now basically we're going to set the condition in there. So the logic here is that if the button is pressed, then we want to turn the light off. Sorry, turn the light on. But if the button, you know what, I'm just going to say otherwise. In other words, that's our else condition. Otherwise, we will turn the light off. So how do we turn the light on? Well, we do a digital write of the green LED, and we want this to be on. And here's our else. Well, how do we turn the light off? It's a digital right of the green LED off. And that's it. So let's make sure this program compiles. Put in that check mark button, and then we see there's no error, so we're going to assume that it works. So let's plug in our Arduino. So I'll plug in my Arduino here. So there it is. And let me, the green light's on, so I had this on before. It's remnants of the program that was in there before, so let me upload it. So that's why in our setup we just want to, if something was on already, just go off and explicitly turn it off. So there we saw that the light is off, and now hopefully when we press the button the light turns on. So here we're going to do it. There we are, the light's turning on, and if I let go of the button, the light comes off. So here, as soon as I let go, the button comes off, and have it down, the button comes on. Okay, so I just want to, before I move on to the next state, I just want to show you something on how maybe we could determine troubleshooting. So let's say we hook this up and it doesn't work. The code looks right, could be a hardware issue. So where we might start investigating is, well, there are two things that might be wrong. Either the LED's burnt out, so that's why the light's not coming on, or LED's not hooked up correctly, or a button's not hooked up correctly. We could sort of swap in LEDs to say, well, let's see what's happening. Maybe LED's burnt out. But I just want to show you something to see if we could actually, the button is hooked up correctly. So what we're doing right here is we're outputting to the light. But again, we don't know if the light is actually working or whatever. So it'll be nice if we can see this another way. So when we debug in Arduino, it allows us to sort of do that a little bit with the input. So just look at the code here. So one of the things that we can do in the setup is here we want to maybe turn on what we call the serial monitor to help us debug our Arduino circuit, if you want to call it that. So the command to do that will be serial with a capital S. So that's another thing to note, it's case sensitive. Begin, and the number put in here is 900, short for the baud. So basically we're turning on the serial monitor, and I'll show you how to see that afterwards. And then right here, what we could do is we could do a print. So similar to what we do in Python when we want to see a status of a variable. Can't see anything on here. So that's the thing. That's why we need this other monitor, is that we could actually do a print. So here we would do a serial.print line. So the command to print in this code is, in the Arduino programming language is print line, not print. In this case, what is it we want to print? We want to print the value of the button state. Okay, so when we run this, so let me compile it first, and we upload it. Okay, so let's say we do this and we press it and the button and the light's not coming on, and we're pressing it, and we're saying, I don't know if the button's actually working. So if we go into, tools, there's this thing called serial monitor. So the shortcut would be Shift Command M. So we pull up the serial monitor, and what comes up here is, and let me just shorten this screen a bit, is, I don't know if you could tell, but there's a whole bunch of zeros printed. Okay, So this tells me that the value of button state is 0. And the reason 0 is getting printed is, remember, this code is being looped. It's going over and over and over and over again. So it's reading the button state, reading the button state, reading the button state. Is the button being pressed? Is the button being pressed? And it's printed this value 0. So now when I press the button, what we should see is something that's not 0. Intuitively, I would think it's 1. So let's press the button. We can know the button. So since we got it working, we know the light's going to come on. But notice when the button is pressed, 1s are coming out. And so notice as I'm holding on the button, the digital read is saying, well, what's the button saying? Well, it's on, so that's what it's printing out the 1s. If I let go, it's got the 0s, and hopefully at the same time, I don't know if we can see the light turned off as well. So if I press the button, we see 1s and the light is on. And if I let go, we see 0s and the light is off. So at least with the serial monitor, we could tell that there's input coming in and the button is working. And if for some reason our light is not coming on, either we hooked up the light incorrectly, the light's burnt out, or worst case, better scenario is that something's wrong with our code. Okay, so that's how we do that. So let me stop the monitor. Let me just close the window. So this in itself isn't that interesting. If we want to turn the light on and keep it on, we don't want somebody to just keep holding on the button. So we're going to sort of transition this into a toggle button. So I'm going to keep this source, and maybe what we'll do is we'll open up a new file. Okay, and we'll save this as it's for some. I think there's a setting that maybe we could do in there to sort of remember where to save our projects all the time. So by default, it's going to this Arduino directory. So we're going to go to our Google Drive again. Find your course folder, and we'll stick this into programming notes again. So here we'll create another one, and maybe we'll call this a toggle button. So let's save that. So now the difference between a toggle button is to sort of demonstrate last time is sort of like a light. What we want to do is when we hit the button where the light's off, then we want to turn it on. And even when we let go of the button, we want that light to stay on. And then the next time the button is pressed, then we want to turn it off. So that's what we call a toggle. So how do we set that up? Well, I'm going to cut and paste this code that we have into another project because I could have called it a different version, but really in essence we're doing something totally different. So copy that and let me paste that into here. So we're going to start off with our program operating just like a push button. Oops, there's the resize there. So how do we do this? So one of the things I'm going to do is, I can't see everything. There we go. Is let's disable the serial for now because we don't want to add. This actually slows down everything. When we do this print is actually a very expensive operation, so it's actually going to slow down things. So let's just sort of comment that out for now. And we want to read, and in here we want to be able to read the button. So what we want to do is really we want to remember the state of not just the button, but also the light. And what happens if when the button is pressed, we want to change the state of the light. So in this case, I'm going to introduce another variable. It's not going to be constant because it's going to be changing. So there's going to be an integer, and maybe I'll call this green light. And I call state. I'm going to actually call this status. No, state. I can leave it as state. And maybe I'll set this to 0 for now. So maybe actually I'm going to use the words off. Okay, so initially we maybe say that the light is off. So in here we're going to do maybe the digital write. Instead of being off, we could just say whatever the light is, the state the light is in. So really our setup has not really changed, but it's really going to be the logic of our code. Here we're going to get the button still. And so in the rest of this code here is we need to do a different logic when the button is pressed. When the button is pressed, we don't always want to turn it on. What we want to do is we want to check the state. So here, what we want to do is if, got the variable name already, green light state. If the green light state is on, in other words, the light is already on, well, what is it that we want to do? Well, we want to change the state of the light to be off. Otherwise, well, in this case, we're going to set the variables for green light state. It's either going to be on or off. Otherwise, so maybe in this case, I'll comment if the light is not on, it must be off. No halvesies. So there we go. If the light is on, not on, it must be off. So in this case, we want to turn the green light state to be on. I have an extra bracket here. Okay. One way, and actually maybe I could have started this way, is we could have actually turned the lights on and off within here. So maybe I'll demonstrate that. So notice that when we set the variable, we're not actually turning the light on and off. How do we actually turn the light on and off? We need to do a digital write. So in this case, if the light is on, then what we want to do is we want to do a digital write of the green light off. So the green light to be off. And then we also have to say, well, now the state of the light is off. Otherwise, that means the light must be off. Then we want to turn the light on. So we're going to do a digital write green light on. And then we're going to remember the state is turning it on. Do we need an else condition if the button is pressed? Well, what happens if the button is pressed, not pressed? Do we need to do anything? No. In this case, nothing needs to be done. Nothing is changing. The only time things are changing is when the button's actually pressed. So what we're going to do here is we don't actually need this else condition anymore. In other words, we only want to do something if the button is pressed. So the logic again, actually I should change this comment now. If the button is pressed, then we want to turn the light on if it was off. If it was off, and turn it off if it was on. If it was on. In other words, have our push button act like a toggle. Okay, toggle is a term that usually means going back between two things, back and forth. So on and off, yes and no. So that's what a toggle, a definition of a toggle is. So there's a code. If the button is on, so we see the button is being pressed, then we want to turn it on. If the light is on, then we want to turn it off. Then say, remember that the state is off. Otherwise, then we know the light is not on, so we're going to turn it on and say that the state is actually on. So let's see if this actually builds. Did I make any typos? I did. Digital write green light. It was not. Oh, green LED. Sorry, I got the wrong variable name. Green LED. Let's try that. So it seems to compile. So let's run this. Let's upload it. So just upload it. So by default, the light is not on. That's what we set in the status, sorry, in the setup. So let me press the button and the light is on. And notice that I'm not pressing the button, the light stays on. So now if I press the button again, the light turns off. Okay, so sometimes the button might be finicky. That's why I didn't turn off originally, but here it's turn off. And again, I'm not holding the button and the light is off. Let me turn it on again and the light comes on and I turn it off. Oh, it's finicky again. Let me do that. And the light goes off. So let me go back to the code that I was talking about. So here we actually duplicated, or we did a little too much. Notice that we're always sending the signal to the green LED, whether the button is whether it was on before or not. So really the difference is what signal are we sending? Are we sending on or off? So we could actually make this code a little bit more efficient in saying that, well, no matter if the light is on or not, we want to send a signal, so digital write, to the green LED. Got the right variable name this time. And this, instead of now saying explicitly on and off, we just want to say, well, send the signal that whatever the status should be. So in this case, it's the green light state. And maybe that's why I got confused, because I got green LED and green light. So not the best of the naming conventions, but since I already typed it in, we'll just leave it at that. So here we're just going to need one digital write. So maybe instead of deleting it, I'll comment this out. So again, comments 2 slashes. So here we're going to set that state where the light should be. So if it's on, we're going to say it's off. And if it's off, then we say it's on. And then actually make that digital write. So this program should now work exactly as it did before, except the coding was a little bit more robust and efficient. And so upload it. Let me confirm. Let me press that button again. Yeah. There we go, done uploading, and let's see if the program still works. So here, press the button. Oh, what happened there? So there we go, on. Oh, happened again. On, off. Oops, off. So there is a little flaw in our program, and this is what I don't know if you can notice when I was clicking. I was trying to click it really fast. Let's say that we're a little bit slow in releasing the button. And what happens? The light turned off. Let's try that again. See if I'm slowly releasing it and the button's turning off. Why isn't it staying on? Idea is if I hold it a little bit too long, the light should come off. Let me try that again. That'll make it explicit. So I hold it out for a long period of time, and as soon as I let go, the light's coming off. Okay, so there I held it down a little bit longer, and then it turned off. Well, why is that the case? Well, what's happening is, remember, our code is looping constantly. So it's constantly checking for a button state. So the first time if I press it down, when the light was off, I press it down and it says, well, the light was off, so I'm going to turn the light on. All right? So the light comes on, but you notice I haven't released the button yet. So that signal is still being sent. So by the time we get back to the top of the loop is coming back down, it thinks I pressed the button again. When in reality, I didn't press the button again, I just didn't release the button yet. So because it's happening so fast, and this is why when I did it, I had to click it really quick and let go really quick, so that within that one loop, it saw that I stopped pressing it again by the time it gets to the next time. So to sort of play around with that a little bit, after we've done this, in other words, after we sort of toggle this a little bit, where we turn it on and off, we actually want to slow down or pause the program a little bit. So I want to add a delay to the button, to our code, so that after the button, we press the button, we just want to not read the signal again right away. We just want to pause a little bit. So the code, the command to pause or delay again was just delay. And here we're going to play around with the value a little bit. So maybe we'll just put in a variable delay time, and up here we'll define a constant int delay time, And maybe let's set this to be 1/4 of a second, so 250 milliseconds. Let's build that. Beautiful, works. Let's upload it. So then uploading, so let's try this. So I'm going to press the button. Good. So just try to hold the button a little bit longer, and let's just hopefully it doesn't turn off. Oop, a little bit too long. Oh, a little bit too long again. Well, that was better. Okay, so let's be really slow on this, and let's give it a little bit longer delay of 500, so half a second. So we'll allow the user half a second to be on that button, and it not really changing, flip-flopping the state. So it's uploaded. So let's try this. So yeah, I held it down a little bit longer than that this time, and it stayed on. I don't know if you saw that. So a little bit longer, it stayed on. Okay. The problem with a longer delay is that if I wanted this bulb to flash really fast, so by pressing the button on and off really quick, I can't do that. So I'm pressing it, I'm clicking a lot, but it's not flashing as much as I'm clicking because I'm clicking more times than in that half a second. So this is where I want to say I sort of want to play around with this number a little bit. So 500 may be a little bit too long. 250 was a little too short, so maybe we'll try 300. And so this is where the sort of the fine tuning goes when we sort of put our project together and you're dealing with a button, is how much latency do we want the user to have in terms of pressing a button or releasing it. So in this case, no, so the latency here is still too slow because it's not going as fast as my click. So maybe I'll come back down to, let's say, 250, and hopefully maybe that's in the range that I'm sort of looking for. So let's just test the beginning. So at least a decent click is leaving it on. And now if I try to do it faster, it's responding pretty good. Okay, so this one idiosyncrasy that kind of be aware of, that this code in here is looping consistently, and so it's always going to be checking whether the button is being pressed. So if that's doing it too fast, then we may get inadvertent results. All right, so good luck in playing around with this button. I've also put some exercises in there where we're going to have 2 light bulbs in there and sort of the button doing different things. And then the very last one is introducing yet a second button. So how do we program 2 buttons now, and each button causing the lights to do different things. So good luck in that, and hopefully you are successful in your attempts.